So welcome to this latest video on 162 Maths, and in this video we'll be recapping the GCSE Maths high topic of trigonometry with a focus of the cosine rule. Now in this video I'll go through the formulas, when to use the cosine rule, and both the two formulas and what is given to you in the exam, before going through some common trigonometry cosine rule exam questions. Now before we get started, let's just have a quick recap on the cosine rule. Now the most important thing is labeling the triangle. Now when labeling a triangle, on this diagram will be given to you on the formula sheet or on the insert of your exam paper. So it isn't actually essential for you to remember the labeling of the triangle, but make sure you do know how to label a triangle when given a non-right angle triangle. Now, a common question I always get asked is, when do you use the cosine rule? Well, for the cosine rule, it generally applies when you've got non-right angle triangles, and you use the cosine rule when you know three sides and one angle, where one of them is what you're wanting to find. So either x or theta, or basically what you want to find, whether it be a side or one of those angles. And a good tip is that when you know that you've got to use the cosine rule, is always start by labeling the angle or known angle, or the angle that you want, by calling that A. With the sine rule, it doesn't really matter what you call it, but I would personally recommend that when using the cosine rule, always start by the angle in question, labeling that as A. Now when it comes to the formulas, now the formula that's going to be given to you in your exam is going to be this one. Now this one is primarily known as the cosine rule, and this one is basically where the missing side is A. Now the key thing to remember here, that with the answer, don't forget to square root. Now obviously if you look at when you do have your answer, see how realistic that answer is for being a length on the triangle. Now the second formula is just a rearrangement of the first formula, and this is used generally to find the missing angle, and we'll call the missing angle is A. And the key thing to remember with this is, don't forget to inverse cos, which is going to be quite obvious, because when you substitute the A, B, C values into the cos A formula, you'll have an answer that is between -1 and 1, and it just won't make any sense for that to equal an angle. So you'd have to, it kind of prompts you to use the inverse sine function. Now it's worth noting, before we go through working through some past exam questions, that even when using the cosine or the sine rule, the exact values of trig still apply. If anything, there is more exact values of trig you need to know. Now when it comes to cos, you can only have angles that are 30, 45 or 60, and the values of those are either going to be √3/2, cos 45 is √2/2, or you could write it as 1/√2, and cos 60 is a half. Then for sine rule, depending on whether it's an acute angle or an obtuse angle, you could have either. So here we've got either cos 30 and sine 150 is a half. We've got sine 45 and sine 135 either equals √2/2 or 1/√2, depending on whether you want the rationalised answer or the non-rationalised denominator answer. And sine 60 and sine 120 is √3/2. So if you do find a cosine or a sine rule question on the non-calculator paper, it's going to be using one of these values. So let's get straight into question 1. So question 1 says, which of the following are the correct versions of the cosine rule for this triangle? It says circle all that are correct. Now this question, I'll tell you in advance, is quite sneaky, not only because they have used different letters to the cosine rule and the diagram, in which they've used W, X, Y instead of A, B, C, but also, as it's worth 2 marks, you may be only thinking that there are only 2 correct answers, but actually there are actually more. So let me talk you through how to approach this particular question. So first of all, I would start by looking at the options that we have and seeing which letters are the subject. So here you can see you've got x squared the subject, and you've got a choice of y squared the subject. Now if I make x squared the subject, then that means that this angle here must be A, this will be little a, this will be B, and this will be C. And again, that might not be the case B and C, that could be switched. So if I start by writing down the cosine rule, in which here I've got x squared equals, and it's going to be, or actually let me write down the actual official one, which is a squared equals b squared plus c squared minus 2bc cos a. But instead of writing a, I'm going to use x. Instead of writing b, I'm going to use w. Instead of writing c, I'm going to write y. So here then I get x squared equals w squared plus y squared minus 2wy cos x. Now looking at this, I can see that this one here is correct. And then if I then go for the other cosine rule, which is cos a equals b squared plus c squared minus a squared all over 2bc. And again, substituting those for the letters that are in this particular question, I've got cos x equals, and it's going to be w squared plus y squared minus x squared all over 2wy, which gives me none of the others. I don't know why I did that one. Right, so the next one that we then need to move on to is when y is the subject. So if I just get rid of all of this, and I can also get rid of all this, not that you would rub any of this out in your exam. So if I made y a, this would be little a, and then going in alphabetical order, let's go for this one being, well, let's have a look at the letters. So I would say, let's go for w being b and x being c. So here then what I've got is I've got w squared equals, and it's going to be x squared plus w squared minus 2xw cos y, and that is this one. Then if I do the cos y version, so cos y equals, and it's going to be x squared plus w squared minus y squared over 2xw. I also notice that this one here is also going to be correct. So actually, even though there's only 2 marks, there are 3 correct answers out of the choice of 6. Question 2, it says work out the value of x. Now again, just to go back, how do I know this is a cosine rule? Well, I know it's a cosine rule because I've got 3 sides and an angle where one of the sides is what I'm looking for, which is the letter x. So I know it's going to be the cosine rule. The next thing I then need to do is to label. So this is going to be a, this is going to be little a, this is going to be b, and that's going to be curly c. Now again, with b and c, it doesn't matter which order you do them in. As long as a is correct when using the cosine rule, it's all looking good. So from this, substituting numbers in. Now, a question I always get asked is, do I need to write down the cosine rule formula in terms of A, B and C? And the answer to that is no. Because the formula is going to be given to you, you're not going to get a mark for it because, again, it's already given to you. But what you will get marked for is using the cosine rule formula. So always make sure that you're showing your substitution. Try not to go straight into your calculator and for 3 marks thinking that you're just going to get an answer. All those 3 marks for just giving one number. So here we've got x squared equals, and we've got 12 squared plus 18 squared minus 2 times 12 times 18 times cos 50. Now, one thing I like to do when typing into a calculator, I like to put brackets around the 2bc. So again, if I just go straight into the calculator, now I personally wouldn't go straight into square rooting. I would write down the x squared value. So here we've got 12 squared plus 18 squared minus bracket 2 times 12 times 18 times cos of 15. I just need to make sure I put 2 closing brackets there, press equals, and I get 190.315. It's 190.315. Now I don't need to write all those numbers. I'm just going to add a few dots there just to imply that the decimal number does carry on. And then all that's left for me to do is to square root the answer, which if I've left on my calculator, it should just be ands, in which here I get 13.8 to 1 decimal place. And then it's just worth just double checking to make sure that I did round that up correctly. Yes, I have. So let's move on to question 3. So looking at question 3, it says work out the value of angle x. So again, I know straight away it's going to be a cosine rule because I know 3 sides and an angle where one of them is x. So then starting with this angle, and label that as A. So this is going to be little a, that's going to be B, and that's going to be curly cur. So then substituting numbers in, this time I'm going to use the cos A version. So I've got cos A equals, and it's B squared plus C squared minus A squared divided by 2 times B times C, which is 8. And I can write that, let me rub that out, make it a little bit clearer. There we go. And so cos A equals, now if I type that all into my calculator, and let me just show you how I do that. So I set up my fraction button, then 9 squared plus 8 squared minus 6 squared all over 2 times 9 times 8. Press equals, and as you can see, I end up with 0 point something. That doesn't look like the size of an angle, so clearly I'm missing something, but I'm just going to write that number down so I don't forget. So it's 7569. And then all that's left for me to do is to inverse cos that number. So if I press shift, inverse cos, then the answer, press equals, and that looks more like an angle I'm trying to find, which is 40.8 to 1 decimal place. There we go. Moving on to question 4, it says calculate the perimeter of the triangle above. So in order to work out the perimeter, I need to know all 3 sides. So let's start by labeling this missing side x. I know it's going to be the cosine rule because I know 3 sides and an angle where one of them is x. So then working out x first, so I've got x squared equals 5.4 squared plus 7.2 squared minus 2 times 5.4 times 7.2 times cos 43. Then if I type that all into my calculator, which I'll do quickly by using the calculator I've got in my hand, squared plus and I get an x squared value of 24.129, and so x equals the square root of that number, which is 4.91. So that's my value of x. So then all that's left for me to do is work out the perimeter. So it's 4.91, which is still on my calculator, so I'll use the exact value, plus 5.4 plus 7.2. So plus 5.4 plus 7.2, and it gives me a perimeter of 17.5, and that's to 1 decimal place. Now the exact answer I've got on my calculator is 17.15222.314. So any answer around 17.5 will be fine as long as you show clear working out like I've done on the screen. Then moving on to question 5, it says 2 soldiers, Alan and Brian, leave their base at the same time. After 1 hour, Alan's walked 5 kilometers due north, while Brian has walked 6 kilometers due southeast. How far apart are the soldiers after 1 hour? So this incorporates a bit of bearing. So if I start by just drawing my general dot. Now north is basically straight ahead. And I'm just going to put a little dot. And this is where Alan is, and that is 5 kilometers. Now southeast is, well, there's east, so southeast is in between. So it's going to be somewhere along here. I'm just going to write a little dot, and that's B. And it says that Brian has walked 6 kilometers. Now in terms of this angle here, now the question's asking how far apart are they? So if I draw my line there, excuse the lack of a triangle there. Now to work out this internal angle, well, this is 90 degrees and this is 45 degrees, giving me a total of 135 degrees. And again, if you're not sure how that's done, is, well, in a compass point, each little bit is 45, and 3 lots of 45 equals 135. So there's the angle. So looking at the triangle, all that's left for me to do, establish which rule. Well, because I know 3 sides and an angle where one of them is the unknown, it's going to be the cosine rule. So then labeling this up, I've got this is angle A, so that's going to be A, that's going to be B, that's going to be curly cut. So here I've got x squared equals 5 squared plus 6 squared minus 2 times 5 times 6 times cos 135. Type that all into my calculator. So 25 plus 36 minus 2 times 5 times 6 times cos 135. Press equals, and I get an answer of 61 plus 30 root 2. So I could just write that down as it is on the calculator, because that's not going to be my final answer, but it's what my calculator has told me. And then square root that number, and it comes up as 10.2 kilometers, and that's been rounded to 1 decimal place. The next question then says ABC is a triangle in which AB is 8.2 centimeters, BC is 14.6 centimeters, and A to C is 10.5 centimeters. Calculate the size of the largest angle of triangle ABC. So let's first of all start by having a look about what this triangle will look like. So for starters, we can start by taking 8.2. So let's just imagine this is 8.2, and this is point A, and this is point B. Now B to C is going to be 14.6 centimeters. So let's just mark that C, and that's 14.6. And A to C is 10.5 centimeters. Now, one thing you could do is to draw this out accurately using a compass and a pencil, and to try and gauge which angle is going to be which, because obviously that will determine what you call A, what you call B, what you call C. But looking at the diagram, if we look at it actually more accurately, so let me start by changing that, because that is going to be slightly wrong. So I would say it's going to look something like this, in which I would personally say, this is no guarantee, I would say angle A is going to be our largest angle. So let me just start by relabeling this. So B to C is 14.6 and A to C is 10.5. And let's just start by working this angle out here. So working that with angle A, so I've got cos A equals, and it's going to be, well, that's going to be A, that's going to be B, that's going to be C. So here I've got 10.5 squared plus 8.2 squared minus 14.6 squared divided by 2 times 10.5 times 8.2, in which cos A equals, and so let me just quickly work that out. So 10.5 squared plus and I get a negative answer, so it's minus 29 over 140, but that's absolutely fine because it's still a proper fraction. So therefore A is going to equal the inverse cos of the answer, which is 101.9. Well, actually it's going to be 102. So let me just correct that. So that's going to be 102.0 to 1 decimal place. Now, just to make sure, I could work out what angle B is going to be. So let's just work out this. So if I call this angle A, that's going to be A, that's going to be B, and that's going to be C. So then if I just call that cos A, then we can just double make sure we've got 14.6 squared plus 8.2 squared minus 10.5 squared, all divided by 2 times 14.6 times 8.2. So just quickly typing that all into my calculator, and let's see if my first guess of seeing whether my first answer was going to be the biggest angle. In which I get 415 over 584 inverse cos the answer, in which I get 44.7 degrees. Now if I then imagined that if I use a different colour, what have I not used? Purple. So this was A, then this would be A, that will be B. Let me not do that, so because it might seem confusing to what I already did. And this one being C, then cos A would equal, and it would be 14.6 squared plus 10.5 squared minus 8.2 squared, all divided by 2 times 14.6 times 10.5. So let me just quickly type that in. And again, this would not be essential if you're drawing it accurately, but I would definitely double check, because you always want to make sure, because you don't know which one it is, particularly if they haven't given you a scale drawing or an accurate drawing, in which I get 8539 over 10220 inverse cos that answer, and I get 33.3 degrees. So out of those three angles, which one is the biggest? This one is here. So we want to make sure we're giving our answer to 3 sig fig. So our final answer is 102 degrees. Then moving on to question 7, it says the diagram shows a shape made from a triangle joined with a semicircle. Work out the area of the whole shape. Now for this, what we need to do is we need to first of all work out what this blue line here is going to be. Now I need that blue line not only to work out the area of the triangle, but also to know the diameter of the circle and therefore work out the radius, so I can then work out the area of the semicircle. So if I take this triangle out, which I'll just do over here, I've got 103, that's going to be 18, and that's going to be 14. So this is the length that I need to work out here. So again, 3 sides and angle, it's going to be the cosine rule. So here I've got x squared equals 18 squared plus 14 squared minus 2 times 18 times 14 times cos 103. Now typing that all into my calculator, I'm going to get an answer of and it's 633.375. So therefore x equals square root of that number, which is 25.16, blah blah blah. Now if you want to use the exact value, that's absolutely fine. If you want to round it, I'd probably round it to a few decimal places like 2 or 3. I'm going to use the exact value, so x is 25.16. If you want to write down the entire number, that's absolutely fine, but it's 25.166949919. That's what my calculator tells me. So then the radius is going to be half of that, equals x over 2. So the radius equals 12.583. So then the area of the semicircle is going to be pi times 12.583 squared divided by 2. And if I work that out, so that squared times pi divided by 2 gives me 248.725911. So that's the area of the semicircle. Then to work out the area of the triangle, well, I'm going to use half AB sine C. So this is going to be my A, that's going to be my B, and this is going to be my sine C. So I've got half times 18 times 14 times sine of 103. And typing that all into my calculator, I get an answer of 122.7706. So then the total area, let me do that in a different colour, So the total area is going to be 122.77 plus 248.725, and depending on your rounding, you should have an answer of around about 371.5, and that's to 1 decimal place, and the units are in centimetre squared. And that concludes the end of this question paper.